There is some background voice for someone. Background noise.
It could be the fan on my computer.
I see.
I cannot help with that.
Okay. I understand. I think it's better now. So. Okay.
More or less. Can try to cool it down.
Yeah. So thank you for actually joining this panel discussion. So I think it was a wonderful day for all of us, and we have got a wide range of topics covered by different experts, also some young researchers. Okay, this session basically just to rewind some of the discussion that we have shared during the day, also take some of the questions from the audience. Okay, so I have done some open-ended question, which basically I will request all of you to give your feedback in general. Okay, then we can go for some specific questions. Just give me a minute. So one of the things that we were like listening to other talks, at least during the analysis, the contamination during sample preparation and sampling was something like repeatedly highlighted by many speakers, and same was mentioned today also, I think. So what are the kind of guidance? Okay, now we have analytical expert also like Nick. So at least for GC, what kind of clean sample that he would like to see and how that should be taken care during sampling and also sample preparation. So I basically request Professor like Walter, Joanna, and Nick to speak on this.
Yeah, I mean, I think it's really important to understand your materials and your backgrounds. As far as possible, create model systems and do model analysis tests to establish where the contamination can come from, and then introduce measures in the workflow to mitigate it. So, yeah, I mean, this is really relevant throughout the whole workflow process, really. So it's about being able to measure and validate at every stage, so you have that understanding, I would say.
Okay. Yeah, Prof. Walter, what is your view on this?
Well, we, as I mentioned, I'm not an analytical chemist by background. What we have done, essentially, we worked on developing methods for the analysis, and when it came to studying the degradation paths and routes and the products, we used to begin with virgin polymers. So we took virgin polymers without additives. We grounded it to micron size, and then we aged it in a solar chamber. So we are aware of the problem of the contamination, environmental contamination, of the lab contamination, but we did not really look at that because we had a little different focus to begin with.
Yeah, I understand. Sure, yeah. Jonah, I think you have a lot of experience on the real world sample handling, and I think you can share at least some kind of tips.
With contaminations, unfortunately, because sometimes there were times that we thought we were doing a paper on samples, and then we ended up doing a paper on contamination, because at the end we found out that most of the particles were not from the sampling, but from the contamination. So this is, and it was very similar to the concentration everybody else was finding in the environment. So this shows how easy one can be fooled by the contamination. And it really looks like the particles you'd find in the environment, because microplastics really are everywhere, as you know. They are in our lives, in our laboratories, in our clothing, in our skin, in the materials we use, in the solutions we use. You'd be surprised with the amount of fibers you can find if you filter your acids, your distilled water, even your salts. There's a lot of people using the salt solutions directly. They are full. The salts are full of fibers, and often they come packaged in plastics. All these are considerations to take into account. Filter everything, burn everything that you can. For instance, we use glass fiber filters. We burn them to make sure they don't have fibers. We wash our glass materials in acid first and then distilled water. We avoid completely the use of plastics, except once we use them in ecotoxicity testing, microplates. We could not avoid that at that time, but we use the protocol to clean the microplates from microplastics. Use a laminar flow hood if you can, because they still have microplastics and fibers inside, but they have less. You can control it better. Clean your lab, have at least a weekly schedule, and you have to have a schedule, because if you don't have a schedule, people will not clean it and you will forget. So have a good schedule to clean it, and have those mops that gather the particles, the dust, so you do not just lift the dust. Close all windows, close the doors, wear cotton lab coats. It's very tiring. Use blanks everywhere so you can find what's going on if you have a problem.
Yeah, blanks is the point. You know,
Yeah.
At least you have to use the blanks to figure out what's going on.
The blanks everywhere, including field blanks. Most blanks in the studies are procedural blanks, but you should also have field blanks. When you go collect the samples, you should also have blanks from that. So it's tiring to try to keep it clean.
So are we looking to consider a kind of clean laboratory to handle such analysis?
Ideally. But we know most people don't have access to that. So we have to work what we have.
We have a lab in my department where they work on Arctic. So they have to work in the clean lab. But can you imagine working on a clean lab to map environmental pollution by microplastics in a large number? I mean, the resources that would be needed are impossible to really be available. Using blanks, it can avoid. You make mistakes a little bit, but you have duplicate, replicate blanks, and then you subtract some that's much more feasible, because even if you clean the lab, I mean,
you still have particles.
Difficult.
Yeah, it's a challenge that we have
the blanks in any case.
So we have to
the blanks should be present.
Yeah, I was just going to add to the discussion that you should be doing blanks throughout your project. So don't sort of do the blanks at the start and then do the project, because contamination might be creeping in later in your work, or later because the lab becomes dirtier. I mean, we obviously try to maintain the highest standards of, you might call it hygiene, and using a safety cabinet, and filtering our chemicals. But essentially, the more you process and handle a sample, the greater your risks of contamination. In some ways, it's not so bad, that because we do our greatest processing for very sort of complex dirty matrices like sewage sludge, but then they tend to be really full of microplastics, so contamination is relatively trivial to what's in the environment. And when we try to find microplastics in drinking water, we have a pretty minimal processing cleanup, so we're not likely to be introducing too much contamination in our processing. But yes, the danger is people enthusiastically trying to write papers on drinking water or bottled water, and if they haven't done enough controls, you've got to be careful of what they're saying.
That's right. Yeah, you rightly said. Absolutely. Yeah, I think the second open-end question that we got for the discussion is, because now as we hear last 2 days and also with the publications, there are microplastics in the environment. So there is a general question how to get rid of it, how to remove. So I think Professor Johnson can say with on you, like at least for wastewater, drinking water, you have something, you have done it, and how you see the people should add some kind of component in their treatment system so that the wastewater release to the river is not really contributing to the microplastics contamination, at least from now on.
Yeah, I'm not quite sure if I perfectly understood your question. Essentially, most of the treatment, secondary biological treatment, is working well. Tertiary treatment often is another rapid sand filtration methods that they also appear to help. So the removal is generally very good from the effluent wastewater stream. So you're only finding between 5 and 30 microplastics per litre. But I suppose the more environmental issue is these microplastics aren't going away. You've captured them in the sewage sludge, and standard anaerobic digestion is not melting the microplastics. It's only 50 degrees C or something. So you're essentially, well, in the case of the United Kingdom, we put about 60 or 70% of our sewage sludge onto agricultural land. So we're actually just transferring it to the soil. So that's a bit of an open question.
You're right. Actually, there was a presentation by Australian researcher who has actually shared that the microplastic from biosolids, which is basically coming from this kind of this anaerobic digester. Yeah, Prof. Walter, you can share your thoughts. But the question is how to reduce or remove the existing microplastics.
If I know the answer, then I
you'll be somewhere else
and put up a company. No, that's really difficult. My answer was at the end of my presentation that depending on where the microplastics are, in my opinion, they depending on the polymers, so the kind of polymers, they're not that long-lived as one would think. The smaller they become, the more the surface to volume ratio, the more the degradation, the fraction of the polymer mass that is degraded, which means that it's chemically altered. It means that it's chemically reactive, and it starts. I mean, we are starting measuring the amount of fragments that are molecular fragments that are released. It's amazing. They are really emitters of all sorts of molecules, from the smaller ones, which are also often have some toxicity because they're aldehydes and ketones and all that kind of stuff, but also larger fragments, and larger fragments when they're extracted because they're kind of water soluble, they are probably biodegradable at that point. Even the particles, the surface of the particles, I showed you quickly, this study by Professor Kalogerakis in Crete, they are munched up by microorganisms because once they're oxidized, they look more like, the terminal of a polyethylene chain with a carboxyl group is very similar to fatty acid. So, and the microorganisms can biodegrade up to a few hundreds of molecular weight. Okay, so they can really shorten. Once the oxidized group are off, they're finished, and if the polymer is very branched, it's difficult. Different point is the other polymers, and the first day there was this presentation about all the coatings, all the tire particles, and now these polymers, even polyesters, they are quite refractory to biodegradation. Okay, so that requires really photooxidation to get into.
Yeah, Jonah, do you have anything to add? So I think you have done a lot of real world samples for air and water. And yeah, this is a general question, how to remove. So that means
I
whatever
think
we are doing for sample preparation.
I think in the terms of wastewater, as Dr. Andrew said, if we're removing 99%, I think if we're going to apply a technology, we have to look at this as a public investment as well. Are we going to apply a technology just to retain 1%? The efficiency of that, the efficiency gain is very small, and the investment would be very big. And we still don't know if, as Dr. Walter said, if they are accumulating or not. We still don't know if they have effects on the environment or not, because what we have so far, there's no risk assessment. We don't know for certain what the environmental concentrations are because there's no standardized methods. The ecotoxicity testing have been conducted with unrealistic concentrations and unrealistic particles. So far, there's too many knowledge gaps to really know what's going on
Definitely.
and to invest so much money in that. But what we do know is that we could do something to reduce the contamination with plastics. And this could be removing microbeads from products. Before microbeads were introduced in products, we had natural exfoliants. We just did this for economic purpose because plastics are cheaper. We could improve the way we produce the plastics, the waste management, avoid the release of plastics. Of course, I think we should really invest in avoiding the release of plastics to the environment. And of course, then collecting the plastics in the environment and preventing them to break down into plastics, into microplastics. And we've seen this now with the Clean Ocean Project or something like that is cleaning the Pacific garbage patch. This is good, the floating waste, but if we don't, first it only cleans the floating waste, but if we don't stop putting more waste, we won't go anywhere. And since the microplastics are produced mostly from the degradation, the fragmentation of waste, we really need to stop and then let it just go away, as Dr. Walter said. Probably they can just be degraded naturally over a couple of unknown periods of time. So we just need to invest first on stopping the release where we can.
Absolutely.
Yes, we would sort of call that, Joanna, sort of source control, wouldn't we? If we could work out why you and I are losing so much polyethylene and polypropylene from our homes down the sewer, it might make a significant contribution to what's arriving in the river. It's funny, I very much enjoyed Walter's talk earlier today because I've decided to take a few plastic bags, LDPE plastic bags, and just sort of put them in the dark for a few years. And I thought, okay, so there can't be any photo degradation, so we should be fine here. And lo and behold, they're shattering into tinier and tinier pieces each year. So as Walter was saying, once they've had a bit of light and the reaction starts, they're disintegrating, and perhaps around where I'm sitting are these disintegrating plastics. But I don't know what exactly their source is. If we knew that, that would be where we could make a lot of progress.
Yeah, I can just add to that is that we cannot prevent fully microplastics because they will be released from our daily objects. We have computers, we have chairs, we have couches made of synthetic fibers. All of that will release microplastics, and we cannot prevent that. Those microplastics from abrasion in our daily lives, we will not be able to prevent them. Of course, we can open the window, renovate the air in the house, and somehow clean locally or vacuum clean the house more frequently to remove them from our environment. But then we'll have to throw away the vacuum clean bag, and it will end up in the landfill. So we're actually not removing them, just moving them around. But in the end, Microplastics will be produced. It just depends on the amount they will be produced. And we know that the big amount is being produced from plastic waste in the environment. If we can just prevent more plastic waste going in the environment, would be a big start in preventing microplastics as well.
We have another problem, if I may, which is the fact that, if we want to run a parallelism between the vaccines, vaccines are available in Western countries and not as much in other countries that are much in which there is the largest size of the population. Well, plastics, you might know, the inflow into the environment is now mostly from less developed or even if developed more countries with a much larger population. A lot of it from Asia, but Africa as well. And if they develop, they will develop without putting too much resources possibly into prevention, but into developing, into having goods. Which means, I've been traveling a little bit in countries and you see on the fields everywhere plastics, plastic bags, wraps, because they're cheap, because they're practical, because they're effective, and so they are affordable. And the population that needs to have affordable goods is the largest share, and it's mostly in countries where there is no control. No management of this. So this is the big issue. Intercept and stop or reducing 99% of the amount that goes into the environment. And then that 1% is, as Joanna was saying, too costly to take care of. But at that point, we might have some kind of a balance between what the environment can do for us and what the reduction of the damage that we are
doing. To Walter, what Walter said is that also the developed countries were exporting waste, this plastic waste, to developing countries just to attain the recycling targets, which is not good. And each time that a developed country contributes to waste, to mismanage waste, when we release plastic, for instance, if Portugal releases plastic to the ocean, this plastic can go to the shore of a least developed country. So this is a problem as well. We are contributing to this. And this plastic is also being sold by corporations from developed countries. They are the ones benefiting as well. So we're creating a lot of problems of social injustice.
Yeah, Nick, I have a question for you, because tomorrow we have a couple of talks mainly sharing about the microplastic in the air and how it affects the respiratory system, and even it can lead to lung cancer. I think I saw that you have done or you have some ongoing project on this air filter. So what is the challenges you have come across in terms of the sample collection and sample preparation, and what are the kind of some tips for others to at least look into it when they do such analysis?
That's a nice question. It's quite hard to answer because there's so many challenges. Right from first of all, what do you put inside your device and how do you condition your filters beforehand? This is really important. And then, choosing the site and arranging the site, frequency of sampling, duration of sampling. Obviously the weather changes and that will affect. But that's kind of judging it as being part of the overall picture that you want to get for a certain site is, of course, important. But, different times of the year and so on. Then changes to the environment, temporary changes to the sampling site. Then what to do when you bring samples back into the laboratory and you have to handle it. So I think, all of you who know a lot more than I do about microplastics in general have mentioned about the number of steps that you take. Of course, preparation steps are vitally important in order to try to separate out the different areas so that you can kind of have more structure and meaningfulness to your data, but every step you introduce has an extra chance of error. And understanding, for me, it's about understanding all these steps, really, making sure you, where possible, minimize handling, and so on. And yeah, there's really so many things to go through. It's a very extensive program of work for every single minute part of the workflow, in my view.
Okay. Thanks. So the sampling duration, when you do this sample impactor for the size segregation, you have used this sample impactor, right? So that can collect the particles of different size.
Yeah.
And what is the sampling duration? It's like a 24 hours or longer than that?
It varies, actually. Yeah. So 24 hours is one parameter we can apply, and it will depend on how many different filter sizes we use, and if we, there are different devices where we might use one, or we might fractionate. So, absolutely. I mean, and it depends on the location as well. So, the frequency versus the duration are definitely important factors. And I think this is part of the validation of that sampling. Actually, is to study the difference, and then also, how also side by side differences in a certain location, and directional differences as well are very important. So that's all. Understanding that is key in terms of knowing, how valid any results and what how you kind of learn from those based on a certain sample site.
Absolutely, yes. Okay, thank you. Yeah, I think Prof. Johnson, I think we have one question for you, which actually you could not address during your presentation. So may I request your opinion how this endocrine, like contaminants, leaching from plastics and the environmental health, how like, because there is a kind of statement, like the microplastics by itself is posing a problem, but it also can carry this kind of persistent POPs, the persistent organic pollutants. So can it release also? That's a question that.
Yes, thanks. I'm aware of this question about plasticizers. These are sort of the more mobile, sort of oily compounds like bisphenol A, which makes cables and things flexible, and are recognized as weak estrogens. Leaching out of microplastics in the gut of animals may be an issue. This is being considered in a number of ways. Of course, you could imagine that an organism could concentrate microplastics in its gut with these leaching chemicals and therefore reach a high exposure. But what some colleagues have pointed out is, I think it was Bart Coleman's from Amsterdam did a paper on this, saying that there are many matrices that absorb bisphenol A and release them that are natural, organic. Sediments in rivers and the marine environment will be absorbing and release these chemicals, and you've got to argue whether microplastics are a significant sort of pool or release of bisphenol A compared to other sources, and that doesn't seem likely. Also, you have to ask from the chemical point of view whether repartitioning out of the microplastic across the gut liquid and gut wall is whether that partitioning favors the gut or favors the microplastic. So it needn't leach out instantly once you've swallowed a microplastic, and therefore the likelihood that you would get a serious exposure, it doesn't seem like it's a very high risk compared to other ways you could be exposed to bisphenol A. So I kind of wait to be convinced that this is a serious risk at the moment.
Okay. Nick, do you have any kind of experience? Because I saw that you are doing the two-step analysis, thermal desorption and pyrolysis. So have you seen any of these POPs, like chemical or compounds, during your analysis? If microplastic is really carrying these chemicals, did you find anything as part of the thermal desorption screening?
Yeah, we find a lot of things, but I'm kind of very nervous about actually drawing definitive conclusions at the moment because because of all the workflow validation aspects. Because we need to really understand the parameters of the method and where these things are coming from and so on. And this is what we're exploring at the moment. There's a lot there, but we need to be able to we need to build in. I mean, the quality procedures to each step of the method are vitally important to gain a full understanding in order to then be able to draw conclusions when we, even on small sample sets, and then going into larger studies, getting on top of this is really the way in order to be able to provide any conclusions with any degree of confidence.
Okay. Yeah, Prof. Walter, you want to add anything on this?
Well, I don't remember exactly what was that was like 3 years ago, 4 years ago, in a conference here in Italy, where on microplastics, there was a presentation about a study in which they used microplastics. I don't remember exactly what kind, so it was probably they were microparticles, not degraded, but they were fed to this fish, and then they had been exposed to these pops, right? I don't remember even what kind of a molecular pollutant, and the microplastics these molecules, they partition, so they were working as cleaners for the organism. They were taking out the pollutants from the organism because these molecules, of course, they partition between the environment and in fact, what they do, they are effective concentrators. If the environment is mainly water, because the persistent pollutants usually are not very hydrophilic. They can be amphiphilic, which is good for the particles to collect them. Okay, and so since they are good concentrators, even if they enter into an organism that is not polluted, they will not release that much, possibly. Okay, that's my point of view. But of course, numbers is a different story.
Luna, do you have anything to add on this? Talking about
I'm not a specialist in that. I have a colleague working on that. The only thing I know is it really depends on the environmental conditions, for instance, pH, and it will depend on the particle. As we said before, each particle is unique. So we cannot predict what will happen for all particles and for all chemicals. So it will be in each situation, the interaction will be different, depending on these three things: the particle, the chemical, and the environment they are in.
So we have a question from the audience. It's more like asking for some suggestion. Okay, if I want to prepare a synthetic wastewater, including microplastics for some treatment testing, how many particles I should consider to test my treatment efficacy?
Well, the point is not how many. The point is what kind of particles. Again, if you buy from a chemicals provider microspheres of a polymer, that has very, very, very little to do with anything that is a macroplastic in the environment. It has nothing to do in terms of the toxicity. If we want to develop a method for characterization, for measuring, even more or less, so that it could be, but for testing something, no. You need, and the problem is that there is no provider of standards of oxidized, degraded, microscopic plastic particles. Okay, that's an issue, and there are a few groups that are starting working on it. I know that there are people who are working using lasers to produce microparticles. There are different ways of doing it, but the way we do, as I mentioned, we use we have a double approach. We get plastics from the environment and we grind it, but it's also different because if you grind it, the interior is not degraded. Okay, so most of the surface will not be the real one. On the other hand, if we prepare from microparticles of virgin polymer, we prepare by aging the microplastics. That's, in my opinion, more like it. But you cannot easily prepare large amount of that.
For this participant, the question is basically they wanted to do some treatment testing, and where they would like to know like what kind of particles and how many particles we should add to say that our treatment testing technologies or method is working.
So the treatment for removing it?
Yeah, removing. Yeah, basically they are trying to work on removal efficacy, and they want to know as a synthetic sample how many particles we should have inside. I think 100 something. I'm not sure. And
no. No. The numbers are much higher. And the smaller the particles, the larger the number. It's it depends on what is your capacity of measuring what you're doing, because you have to be able to measure what is the rate of capture, and so you need to be able to measure the number of particles. So your system for measuring, if you have you use something that can get you to 20 microns, you cannot go below that. You need to have particles that are larger. If they are too large, if the system that captures the particles is sensitive to the surface composition for absorption, for example, aged particles are different from virgin particles. If the shape is important, depending on the system that you use to capture the particles, a fiber can be captured much more effectively by certain systems than spherical particles. So there are a few parameters that have to be clear in mind when you want to do something that makes sense. Otherwise, you're doing something that doesn't make sense, and you measure 99.9% capture, but then in the real case, maybe you have 50% capture.
I hope at least your feedback would have given them some idea what to look and how to really go about it. Great. Yeah, I think we have done a bit of good discussion here. I just want to highlight the things that we have discussed yesterday. I'm not sure whether all of you were present yesterday. Yesterday, there were like two major points. Again, like today also it was highlighted again. One is the harmonization, even at the technique side. And another one is the sample blank. And third point was, okay, the lack of standard or reference material. And this is where at least the community said, okay, we will try to do something. At least many people have come forward, they're working on different platforms like spectroscopy and chromatography and different thermal analytical techniques to come up with some kind of a sample that can be circulated among the group and at least have some kind of starting base, to really evolve something that can be considered as a reference material for harmonization of the different analytical techniques. Similarly, there was a suggestion to look at the sample preparation kind of tips, how to control or reduce the sample blank. These were some of the points that were. So from today's discussion, at least, we have to get some points that will be taken like forward for our future discussion. So definitely, I have a general question. What will be our recommendation in terms of the sampling, So what are the precautions or what are the gaps that we have to address and how to overcome that? Particularly, we talk about environmental sample like water samples, seawater or river water, and air samples. I think Andrew can start because you have done a lot of real world samples.
Yes, so I mean the basic thing is you prepare, in our case, because we're taking liquid samples, we prepare your filter apparatus in the safety cabinet, in the laboratory, so you seal it, you close valves, and only then do you so you don't minimizes the amount of fiddling around that the operator has to do. With your own sampling equipment, for example, if you have some pump, you might want to start flushing that for a while, so you're not measuring microplastics in your pump as opposed to in the sample. And then you, again, don't allow anyone to sort of interfere with your sampling apparatus filter till it's back in your safety cabinet where you then open it. And I think also, as Joanna pointed out, it's not a bad idea to take some spare sort of apparatus with you, which you don't actually put the sample through, so it's as close as possible as a field blank. So that also checks that you're not getting any other extraneous contamination in the field.
You're muted.
You're muted.
Okay.
Yeah, sorry about that. Nick, do you want to share your thoughts on this sampling?
Yeah, I mean, I agree with everything that Professor Johnson has said. I mean, and really, everyone's kind of touched on this so much. I think it's hard to give a direct answer right now because we're all looking at these things. One thing, just to say that we've considered, Joanna was talking about trying to minimise or understand sampling background and contamination, and so this is one thing where we'd try to set up a collection of particle-free sample side by side in the same location to understand that. That's one thing. And then in terms of a model system or a standard to use in the laboratory, I mean, it's trying to minimize things again. So maybe preparing things in batches and then storing them so they can be directly used in the most efficient way possible is another key point.
I leave this to my colleagues. I stay on my polymer
I think
science expertise.
And I think you are not going to field always, right? So your field is your lab. Yeah.
These issues are the ones that give me a headache because it's not my field. So when they start asking me triplicates and blanks and so on, I understand, but it's really.
Jonah, you can add to it.
Yes. First, I would say that storing the something that we haven't said so far is that storing the samples for long can lead to the loss of particles as well, because microplastics have very electrostatic forces and they can move around. We actually saw this in our samples. We had them stored in petri dishes, glass petri dishes, and then they moved inside the cardboard box to be in the dark, and they moved to the cardboard box. Because they have these strong electrostatic forces and they attach to the glass and they move around and they move from your filter to all the other things. So if you store them for very long, you will lose some of the sample, which is not very good. It's good to work in batches because you can run blanks for each batch, but not store for very long. Regarding the sampling apparatus, actually also do, like Professor Andrew said, we mount, when working with the air sampling, we mount the air inlet with the filters inside the laminar flow hood. We clean everything and we mount it inside the laminar flow hood. We cover it in aluminum foil, put it in a cardboard box, and only mount it in the field and take it back. Also, we do the same with the field blanks. We have one that is like this, just goes with us to the field. We mount, we dismount and carry it back to the lab without filtering the air. For water samples, we carry the glass bottle with us, which we open and close, but we don't sample. Water bottles, usually it's good idea to clean them before sampling. We clean them with acid and distilled water in the lab, but then when we reach, we close it with because usually the lids are plastic, the caps are plastic, so we close them with aluminum foil and then with the plastic. And when we reach the sampling area, we clean them with the water as well, like with the pump. It's good to have some of the sampling water to go there just to clean anything that could be there. So all these precautions are very good practices. As we said, quality control, quality assurance it's good if you want reliable results.
Yeah. I think with that, I think we can wrap up today's session. At least two takeaway message. One is, I think we have to avoid contamination coming from sampling or sampling equipment or sampling. And secondly, we have to consider some kind of harmonization, even for some sampling like filters, or so that at least when people are comparing the data, it is like apple to apple comparison. Otherwise, yesterday Prof. Jess was mentioning, like you compare some data from China versus Europe, totally they are working in different way. So these numbers comparison will not give any kind of meaning. So that's why again it's coming for some kind of harmonization or standardization. I hope this kind of deliberation will lead to some kind of collaboration, where people jointly do something and at least use that knowledge for the next level of group of people to continue. So definitely we'll put things together. That's the idea also that we have like mentioned yesterday also. After this conference, some of the takeaway points we try to put together and see how some of the researchers can really continue the interaction and collaboration. So that will really lead for something to again meet after some time and share things. So definitely that will be the objective of this symposium also. So I once again thank you all for your time and the inputs, experience sharing. I think definitely all the participants would have benefited from this. Again, those whoever missed today, like because of the long day, they will have opportunity to go through our report. And also all these sessions are being recorded. We plan to run like periodically, like now we are given a kind of heavy dose, 7 hours, a lot of information. But we try to do a kind of periodical every 15 days, at least one session where 1 or 2 talks. So the community at least will keep the information flowing, and that also will keep them motivated to advance in their progress. So with that, I would like to thank you all, and let's end this discussion here, and let's meet again tomorrow. Okay, thank you all, and also for the participants for staying back until end. So you all have a nice evening and nice day as per the time zone wherever you are. Take care. Okay, bye-bye.
Bye.
Thank you, everybody. Bye-bye.